Okay, good morning. Hey, Ian, how are you?
Hello, not too bad, Harry. Thank you.
All right. Well, good morning. Are we getting people are starting to arrive?
Good morning to you. Good afternoon
Good
from here.
morning.
Okay, recording has started. My name is Harry Ricker. This is the Cosmology discussion group for January 11, 2026. I welcome everybody. It's a rainy, kind of overcast day here. I hope you're getting better weather where you are.
Same here.
Same weather, or you're hoping for
Well, it's overcast and dull, but the temperature has gone up. It was near zero, but it's
oh
now a
my.
good few degrees above zero.
We have the opposite. It's warm and dropping. Okay, this morning I'm going to talk about Roger Rydin, Roger A. Rydin. Have any of you heard of Roger Rydin? No, Roger Rydin? I know
I think I
Vladimir.
had some exchange with him, maybe along with some others, and I didn't know he died actually. I didn't know that, Harry.
Oh, yes, that was January of 2024. So that would have been 2 years ago. Yeah, that's kind of sad. But he was getting up there. I think he was 88, so he'd be 90, I guess, which is um, okay. I'm going to talk about Roger. Um, okay. Okay, is that looking good?
Yeah.
Yes.
All right. So, as Ian had mentioned, that Ian had some contact with Roger. I had back years ago, many years ago, Roger used to participate in our email discussions, which still go on under the aegis of the CMPS. In those days, it was under the aegis of the National Philosophy Alliance, the NPA. And so Roger was a pretty impressive guy. Had pretty impressive credentials, and so he was a professor emeritus, which is a fancy title meaning that you're a retired professor. And so he was a nuclear engineer at the University of Virginia. So it's a professor of nuclear engineering at the University of Virginia. And he passed away January 8, 2022 at the age of 88. Now, he was, when I looked a little bit, he was apparently the valedictorian of his high school. So that's pretty impressive. And he got a BS in electrical engineering in 1957 from Northwestern. So I think the BS in electrical engineering, Bachelor of Science, I think that's important. We'll find out later. I didn't really realize that he had a degree in electrical engineering until I was looking at his resume. And then he went on to MIT. That's an impressive school. And at MIT, got a doctorate in nuclear engineering. And I think he got another doctorate in something else. But anyway, the important point I think here that I want to emphasize is that he was a participant in the National Natural Philosophy Alliance and went to um, um, conferences that were put on by the NPA. And so he was very much a participant in our dissident science community. Okay. So I, being a dissident, you'd sort of expect what his belief would be that he's kind of a dissident scientist. So this is a statement from one of his papers. It said, if the battle is over, referring to the Big Bang versus the steady state, then why are some people still unhappy with the result? Well, of course, the people that are going to be unhappy with the result are the people that you would meet at the NPA and the NPA conferences. The answer to that question is that a lot of new experimental data has come in over the past 20 years that throws doubt on the very assumptions that went into the theory that GR describes the universe. So Roger is going to base his um, theory, his big wave cosmology, on evidence, not speculation, which our current theory is based on. And so I'm going to try to emphasize the experimental approach that he uses. Now, as far as information about Roger, I discovered that wasn't there's a lot of information out there. It's not really that easy to come up with, I suppose. I did discover that he had a website, but his website, when I went to look at it, was defective. But I did manage to recover it from the Wayback Machine. Um, I don't know if I didn't know that much about how to use the Wayback Machine, so it turned out that was a bit of an adventure trying to recover his website from the Wayback Machine. But I eventually did, and so you can do that. There's the address. He had discovered he has some lectures on YouTube, which is kind of nice. That we actually can get to see Roger talking on YouTube and giving lectures to the MPA. And the main source of information for this discussion is um, some papers that can be found at the General Science Journal. I'm not sure if everybody here is familiar with the General Science Journal. He has a paper with um, on the what's the inverse of archive, VIXRA. That's it, VIXRA. So you can there's papers there at VIXRA and also at uh, academia, I think, and those sites. So he spread some papers around. They're not all the same papers. Most of the papers that he cites are MPA conferences. And now, what I found when I went to look for MPA conferences, they're not available online, or at least I couldn't access them online. And that goes back to when the MPA actually published a proceedings. I don't know if many of you have copies of the MPA proceedings. Um, I don't. And my understanding is that Greg Volk has copies of them. Probably David DeHilster probably has copies, and old people who went to the MPA conferences 20 years or so might still have these, but I couldn't find copies of them online. So that presents kind of a problem for looking into what Roger was talking about. And it's sort of a disappointing thing that we don't have this digitized. That would be helpful to researchers who are interested in some of these work that was done by people back around the year 2000. Okay, so Roger, his work basically reveals some problems with cosmology assumptions. He came the cosmological principle is invalid. Rydin shows that there is a center of universal expansion contrary to the cosmological principle. Now, the cosmological principle says the universe looks the same from any place in the universe, and by implication, there is no center. So Roger says, wait a minute, I think there's a center, and he's going to he produces data that shows that there's a center of expansion of the universe, which I think is quite extraordinary. Then there's the homogeneity principle is invalid. And Rogers shows that the distribution of galaxies is not uniform, but is periodic. periodic with distance from the center of expansion. So not only is there a center of expansion, but there's a, as you go out from the center, he uh, claims that there's evidence which shows that the uniform, that the center, that the density of galaxies is not uniform as you go from the center, that there's a periodic distribution of galaxies. So there's a clumping of galaxies at certain distances, and those distances repeat in a periodic manner. That's kind of another interesting result. Okay. All right. So now we're going to talk a little bit about what he discovered based on the Sloan survey. This is an old survey that was done around the 2000. So it's kind of an old data set, but that was the data set that was available to Roger when he was doing his research around, towards the end of the 2000s, towards the end of the 19th century and the early 2000s. And he says, there is indeed more experimental data that argues that the very assumptions of the cosmological principle do not apply to the evolution of the universe, i.e., general relativity has nothing at all to do with the distribution of matter in the universe. So he's rejecting general relativity based on experimental data. The Sloan survey is remarkably symmetric spherically in all directions from our location. It can also be argued that the density of galaxies as a surrogate for the density of matter seems to decrease radially from the center. So that's another interesting claim that he makes based on analyzing the data. So he's saying that the density is not uniform as we look out, as we go further and further, the number of galaxies decreases. So it's not a constant density as we go away from, look further and further away. And then he says quasars also obey the same pattern. So quasars apparently fall off as you go further and further out. The density of quasars decreases. Spherically symmetric distribution of matter around the position of the Earth is at odds with a uniform expansion as produced from Einstein's GR and explanation point. In other words, the distribution is not the one predicted by the Big Bang. Now, these are quotes. Okay, and notice that he does have explanation points in there. Okay, so, okay. Now, this data claims based on a pencil survey. So he's using um, what they call, what he refers to as a pencil survey, which is that you look out in a certain direction in the sky, okay, over and just in a certain area of the sky, and you look out and you record the number of galaxies and their redshifts in that particular direction. And he says several features can be observed. The data are remarkably symmetric about Earth being at most off-center by about 70 million light years. So he's saying that the center of expansion is 70 million light years away from us. That's not really that far away in cosmological terms. The data are periodic with a period of about 40 million light years. So in these pencil surveys, you see that the number of galaxies is high at certain distances with a periodicity of 400 million light years. And then this is interesting. It says the data are strongly damped with distance from the Earth. Okay, that's an engineering term. And it means that you don't get sharp periods or sharp peaks in your analysis. The peaks are sort of spread out. That's what he means by damped. Okay. Then he has a conclusion here. The general conclusion is that all of the surveys are highly correlated, have the same periodicity, and hence have a common source. Okay. Common source means the center of of the universe, or the center of the universe's expansion. Furthermore, the data can only be consistent with a spherical distribution of galaxies emanating, that's the key word there, emanating from an origin about 70 million light years from Earth in the general direction of Virgo. Virgo is a constellation. The universe is not expanding at all, but the galaxies are each moving in space in a radial direction away from the origin. So he says that the redshift information isn't because the universe is expanding according to general relativity. He says that there's actually a physical motion of the galaxies away from an origin. That's a difference of opinion. Okay, so then his conclusion about this data. What does the pattern of the distribution of galaxies look like when the 1 over r squared correction is added to the pencil data? So he's developed a conclusion. We obtain a pattern that seems to be spreading geometrically from the origin like a spherical explosion, but it is damped beyond that spread by an exponential factor. This is pretty technical information. And superimposed upon all of that is a fixed periodic behavior of great walls and great voids. So his explanation of why we see these walls or places where the galaxy distribution is density. The galaxy density is higher, and then we see other regions where galaxy density is very low, and those are called voids. This is a significant burden for any theory to explain, and a reminder that perhaps the experimental data should be examined carefully before a theory is proposed rather than 90 years later. So what he's saying, in effect, is basically what cosmology has done is they've adopted a theory based on we don't know much about anything, called general relativity, use that theory, okay, made some assumptions to make that theory apply. And we talked about what those assumptions are in the beginning. There's the cosmological principle and the other hypothesis. Okay. And so he's saying, I've looked at the data, and the data, could be, it doesn't really agree with the existing theory. And his reasoning, criticism is we should adopt a theory based on what the data tells us, not what a vague theory called general relativity is telling us. Okay. Rydin has shown, and I'm going to talk a little bit more about his evidence. Rydin has shown that experimental evidence from 6 deep redshift galactic pencil surveys out to about 5 billion light years, and the full Sloan survey indicates that the distribution of galaxies and quasars is actually spherically symmetric about an origin about 70 million light years from Earth in the direction of Virgo. So this is really basically repeating um, what he said. He's repeating basically what he's said previously. And he says that the distribution or density of galaxies decreases with radius approximately as 1 over r squared, and is periodic with a period of approximately 400 million light years. Quasars show a similar periodicity, but they primarily occupy an outer ring at high Z. Okay. This origin, and I talked about that, corresponds to the origin of the CMB, corresponds to the dipole anomaly and the great attractor, and is the direction in which the only known blue shift galaxies are found. So he's kind of trying to argue that what his analysis of the data explains a number of conclusions that have already been arrived at by astronomers. Okay, so now I'm going to talk about his big wave model. And so he's got a theory. Okay, he's looked at the data, and based on that data, now he's going to come up with a theory. Based on fitting experimental evidence on galaxy distributions to a simple quantum mechanics spherical solution that mimics the measured periodic deep galactic redshift distributions. Wow. So he's got a model. Okay. And I was not really able to really, the model is kind of, I didn't really understand exactly what his model is. But I want to mention here and point out something I didn't really talk about earlier, and that is apparently from uh, what I was able to find, his expertise is analyzing data. So he was apparently adept at taking data and processing data and analyzing it. And that's where he's coming up with this periodic distribution and these ideas that he's coming with. So he's a data analysis expert, if you will. That was his expertise as a professor of nuclear engineering. So his claim is the big wave model is the only model ever postulated that has the potential to explain the origin of the periodic great walls of galaxies, explains how galaxies formed in a reasonable period of time, explains why the quasars lie in a spherical annulus surrounding the Earth, and reconciles all the data on the age of the universe. Those are pretty impressive claims, I would think. It reconciles the logical contradiction between the centerless expanding balloon idea that all observers see the same universe and its companion idea that we can almost see the beginning of our universe in all directions just at the far edge of our sight. And it consequently explains why there isn't any missing exotic dark mass. So Roger doesn't now, in this last paragraph, these are basically things that the mainstream believes in. The centerless expanding balloon universe. If you go to cosmology books, they talk about the universe is an expanding balloon, that all observers see the same universe. That's basically the cosmological principle and its companion idea that we can. Now that's the idea that when we look out, we see the CMB. So the CMB is the birth of the universe. That's what he's talking about there. So when we look out with our microwave receivers, we see the birth of the universe very, very far out. Okay. Um, this part here is the four phases of the big wave. This is his attempt to explain why we see what we see, or what his model, the periodicities. So he's saying he's starting with a contraction of the universe. It collapses into a black hole. Now, his black hole isn't the black hole of the mainstream, because the black hole mainstream would just suck everything into it and disappear. But so he doesn't really agree with the black hole idea that the mainstream has, but he's using that terminology. I'm thinking what he means is a dense object, which then explodes, creating photons and graviphotons. Now, so he's invented a new particle here, graviphoton. And I didn't really get a really clear idea what a graviphoton was. So we'll just sort of leave that for further explanation. The photons and graviphotons recombine to form mass again. So that's his idea. So there's a collapse of the universe, okay, and it falls into a black hole and then rebounds, apparently, in this kind of a Big Bang type thing or similar idea. A period of recombination creates the CMB. So he's borrowing the idea of the CMB and the origin, or how the CMB arises. Okay. So he's borrowing that from the mainstream theory. The existence of black hole seeds allows galaxies to form in a reasonable length of time rather than having to wait for random motions to start the process. So I don't really know a lot about this idea of black hole seeds, but apparently this was a popular idea around the year 2000, probably around the start of our current century, around the 2000s, late 90s, 2000s, that there are these black hole seeds. Um, I'm not really sure that that's really too popular now, but he's borrowing that idea, which was apparently at the time a rather popular idea. Okay, so those are the from this, these black hole seeds, then galaxies are created. Okay, now that's just kind of an outline of his theory, and presumably it's kind of incomplete, if you will, and you could sort of reject it on that basis that you want to know more. I basically think maybe there's more that he had in his head, and probably at his website. There's more information at his website. Actually, this part here about um, uh, well, the four phases of the Big Bang. I think I got this from his website. So this is, and the information there isn't really very detailed, if you will. And I didn't really go through everything at his website, and I'm not really sure that the version that I was able to recover was the latest version. So there's a lot more information out there, is what I'm really saying. What I'm really trying to do with this presentation is really point out that Roger did have a theory. He did um, have some ideas. A lot of the ideas are, how should I say it? They're in different areas. He had ideas about nuclear physics modeling, about the nucleus. I don't see Ito here today. He might have been interested in that sort of thing. So people that are interested in the elements and the building up of the elements, he had a theory about that. And so he has a lot of different ideas that he's talking about in his papers and in his website. And I'm just basically only really talking about one of these many different ideas that he had put forward in a number of papers. And I'm just giving a brief description of his thoughts. All right. One of the things I want to point out here about Roger's approach. So Roger's an engineer, trained as an electrical engineer in the beginning, then went into nuclear engineering. And I think there's kind of a difference between how engineers approach science and how scientists approach science. So Roger, he has we see and we look when looking at Roger's papers, okay, particularly about cosmology. Now, I don't claim I looked at all of his papers. I didn't have time to look at them all. This is really just an introduction to his ideas and just to get you interested that maybe going and looking at Rogers' papers might be of interest to you. And that's really what I'm trying to do here is just, it's an introduction more than anything else. Okay, so Rogers' scientific method is observational evidence suggests assumptions underlying GR are not validated, falsifying Friedman models of the Big Bang. Okay, so Roger looks at evidence. Okay, he looks at evidence, he analyzes evidence. And I emphasized this point earlier. Roger is a data analysis guy. He puts data in the computer and runs it through these computer programs and looking for patterns, that sort of thing. So that's so he's done this with the galaxy distribution data that the astronomers have produced, and he's analyzed this and found out that it doesn't really agree with the Big Bang idea is the general relativity models and the assumptions that are involved. So he does I mentioned this, performs data analysis of galaxy distribution data. So he works with the real data, okay, and so his analysis confirms periodicities not predicted by GR models and inconsistent with GR assumptions. Okay, so his method is looking at the data, processing at the data. Okay, you get results. The results suggest this periodicity. Okay, then from that you have the hypothesis to explain. He creates a hypothesis to explain periodic distribution of galaxies and why the density decreases. And his hypothesis is this big wave idea, the collapse and the rebounding. And this occurs periodically. So you get these different expanding waves of galaxies. Okay, so his main hypothesis is that the galaxy distribution is a Bessel function from electrical engineering. Okay, so in the next session, if people are interested, I can show you some of the graphs and that he came up with it basically. And so what he did was a data fit to a Bessel function. Okay, and so that's where you have this expanding waves. Bessel functions are wave functions that are periodic. Okay, so that's kind of an important thing. And then he does, of course, I mentioned here, he does a data analysis to fit to the Bessel function hypothesis. So he produces a computer simulation that shows that his model fits the data. Okay, so I'm going to contrast that with the mainstream. They don't question the assumptions used to establish the accepted standard models. So, you know, um, it's they're just assuming, well, we had this GR theory. Einstein, who was our God, came up with this GR. We have these Friedman models, and these things were developed before they even had Hubble's law. Okay. All of this was set in concrete before Hubble established Hubble's law. Okay. And I think that's an important to note that it's all based, the whole basis of everything that we have in cosmology starts out of pure theory. It doesn't come from experimental evidence. Okay, the other point is they refuse to acknowledge and accept falsification evidence by blocking publication and presentation at meetings. So one of the things that Roger talks about, and I remember him talking about this, was that they refused to allow him to present his data at a colloquium at the University of Virginia. They blocked him from presenting his theory at the University of Virginia. And that really annoyed him a lot. So this is another example of dissident science being blocked by people who claim to be scientists that but obviously don't want to really look at evidence that contradicts their beliefs. So it's kind of more like a religion in this respect. Okay, and the third thing that they do is they invent ad hoc modifications to the standard model to accommodate disconfirming evidence rather than admit falsification. So we have a long litany of this. We have, dark energy, dark matter, that sort of thing. Okay, so we're coming up to the end here. Okay, so I mentioned this, that he was blocked from presenting his results at UVA. That's kind of, I think, that's an important point to, I think, understand.
He was academically, he had a post in UVA, so he was blocked by his own colleagues. Is that so, Harry?
Yes,
Okay.
that's why I'm bringing it up. Yes. And of course, being in academia, they never told him who blocked it. He was never, it was never disclosed who it was that objected to his presenting his results. Okay, I think I've sort of shifted here to the point of from Roger's theory to the sociological aspect of the story. So I'm talking now about the sociological aspect of Roger's experience. And it demonstrates that mainstream academics are unable to tolerate differences of opinion in science. And I think this is a serious problem. And they will promote ad hoc modifications to keep their theory going, no matter how strange and unlikely, rather than discard or allow challenge to a falsified standard model. Okay, so that kind of finishes up here. Uh, I got about 4 minutes. So that's kind of my presentation. Um, and does anybody have any questions before we proceed to the next? Dead silence. Okay.
Well, I understand that you have some data slides to show in the next session. Is that true?
If you're interested in seeing the data,
Yes, one problem I have with just presenting the theoretical points that Roger Rydin made is all kinds of concepts are thrown out without what the data supporting those concepts or indeed operationally defined.
All right. Well, I've given you the wrong impression. I was not able to copy the charts into this presentation. Okay. I would have shown you the charts. Okay. So in a 40-minute presentation, I was not able to copy the charts and the information that he had. Okay, because they're on P. Anyway, I don't want to go into the technical aspects of it. So don't get the impression that it's not a data-oriented argument that he's making. I'm merely pointing out to you, okay, I'm just giving you the summary, the very briefest overview, a very brief overview of a part, only a small part of his, what he's talking about, a very small part of what he's talking about. Okay. You understand what I'm saying?
Yeah, but all I'm pointing
If you want more information, you need to dig into his papers to get it. And as I pointed out previously, some of this information is in MPA proceedings, which has not been put available on the internet. I couldn't find it. And at some point, David DeHilster supposedly had it at the CNPS data repository, but that's no longer being kept up to date. Do you understand what I'm saying here, Jim?
Yeah, and all I'm saying is that we can't really evaluate the concepts that he presented
Yes, you can if you want to dig into it.
Well, I'm saying at present.
I'm just giving you the overview. I'm just giving you it's a 40-minute talk, which is going to be in. I'm just giving you a brief overview, pricey, if you will. You understand what I'm saying?
Yeah, and we have concepts that we can evaluate at this point in time.
Yeah, that's certainly true. The point is you're being encouraged to dig deeper rather than so in other words, the point of this is people should dig deeper into alternative ideas rather than just dismissing them because they don't agree with the standard way people are thinking about cosmology. That was the whole point of what I was saying at the end. The mainstream wants to just ignore it and make it go away.
Well, I support that open-minded approach, yes.
Now, as I'm saying, basically, there's more to it than just this big wave cosmology. There's a lot more to what his ideas are than, do you want me to go over it again?
Uh, I'm not sure I caught where the methodology was.
Well, I explained to you that
Apparently,
he took the
he's
Sloan data and these pencil survey data that these astronomers had produced, and he put it into computer programs and processed it. I thought I
yeah, and I'd
explained that.
like to know what the methodology was used to create that
Oh,
data.
so you mean by methodology, you want to know all of his data analysis programs. Well,
Well,
like I said,
well, apparently, what my focus is right now is the methodology used to create the data that he used as input. And so this is not even about Roger's work. It's about, what is this pencil data? And supposedly there exists some
well,
methodology.
like I said, you need to dig into it. Now, I pointed out where the information sources are. I think I covered all the information sources. And I pointed out that his primary results that he presented were unfortunately in the MPA journal, MPA conference proceedings, and that these MPA conference proceedings are, I don't know how to get hold of them. You could probably contact Greg Volk. My understanding is that, do you know who Greg Volk is?
Who, me?
I'm saying, do people here know who Greg Volk is?
Yes, of course. He used to convene the Saturday sessions, and he has been deeply involved in the conferences years ago.
Right. So that's my suggestion on the idea. I did searches, on the internet, and tried to get copies of the conference proceedings and his references. So this is a problem that you have where, and what happened to the data? MPA kind of went defunct. What happened to the resources of the data that the MPA had? I guess David DeHilster tried to preserve. There was a big argument, as I understand it, about who about control of the data, and David DeHilster tried to establish or preserve the data. He claimed that it belonged to him. I don't really understand the politics of it, but supposedly he kept the database, but that database has sort of not been kept up. So if you go to the Natural Philosophy Wiki, I think is the name of it, and you don't get it gives you errors and that sort of thing. So that's a problem. Okay. The other sources information is his website, but his website, of course, is defunct, and so all you're going to find is what has basically been preserved by the Wayback Machine. Um, and there is a paper, there are some papers at the General Science Journal. I don't know how much, uh, whether they are duplicates of what he presented to the NPA. So without looking at the conferences of the NPA, I don't know whether there's any additional information that you're asking about to be, whether that's all there in the papers at the General Science Journal. There's some, I think there's duplicates at the academia. And I think, what is it, ResearchGate may have some, I'm not really sure about that. Vixra has a paper that he wrote with Stephen Crothers. Um, and then I didn't really go into, there's a lot more going on here than I've just alluded to. I only took like a small slice of what he was working on. Like I mentioned, he was working on a nuclear model, a new model of the nucleus, and magic numbers. I'm not really sure. This is the sort of thing that Ido was talking to us about, the similar type thing. Roger was working on that because remember, he's a nuclear engineer. Okay. Um, and so he does talk about a lot of different things. He has ideas about black holes. There's another guy, Bob Heston. Um, I don't know if this name is familiar to any of you people here. Are you familiar with that name, Ian?
It sort of rings a bell, but I'm not quite sure who it is, Harry.
Right. He was another guy that was active in the early 2000s in the NPA, and he presented a theory. And so there's a lot of the work that Roger talks about is based on his work. Then there's Charles Lucas, who is also involved in this, that Roger was working with Charles Lucas, who is another um, uh, longtime member of the MPA, and used to participate in our Saturday morning discussions on a regular basis. But my understanding is he was in an automobile accident, according to Dennis Allen. And I don't think Dennis knows whether he knows what his health status is. And I guess he's still alive. I haven't heard anything about him dying, but he's apparently not really active anymore in dissident discussions, although he was very active for many years and has a. So this is all. So Roger was working with Bob Heston and Charles Lucas, and also with Stephen Crothers and various things that he was working on. So there's more to it than just this cosmology model. The reason I picked the cosmology model to talk about is because this is a cosmology discussion group. Does that help you any, Jim?
Well, yes, it does. But actually, my query, I guess, is a little bit off topic because I was interested in the data that was used as input that he did not generate himself,
Well, you're
but
talking
was
about
used
the
as
Sloan
input.
survey and the pencil surveys.
Yes, and apparently, you, uh, I'm not sure what the methodology is as a non-astronomer. Okay, and so I guess my query is off topic, but if it is on the topic, how do we how do these surveys determine the distance of a galaxy?
Redshift.
Uh-huh. I thought that had to do with relative motion of the object rather than its distance. How
Well,
does the
it's the Hubble
redshift tell
law.
you the distance?
It's the Hubble law.
The Hubble law.
Well,
Okay.
assuming the Hubble
I
law
thought
is
it had to
correct.
do with the brightness of the galaxy, but I guess I'm completely wrong on that.
Well,
Well,
indirectly,
I can't really answer your question other than you know, he gives references. If you go to his paper, he gives references to the data sources in his papers. Um, I didn't really look at those and study those because my purpose here was not to um, make a thorough analysis or presentation of Rogers' theory. It was merely to pique your interest and point out that Roger had this theory and he did this work. And
Yeah,
um,
that's why my query, I guess, is a little bit off topic because we're talking about uh, uh, Roger Rydin's work, and yeah, so I'm just interested in the work in the data that he used as input, and which was produced by other people. And I had thought that the distance of a galaxy was judged by its brightness, but not, well, I guess we can have another session sometime to talk about elementary astronomy and how these databases are actually created.
well, that's a good point. Uh, the usual assumption is that, my understanding, based on not really having looked at these references in detail, is that what they do is they take a big telescope and they look out, and they have this spectrometer that I think it's got all these different fiber optic cells in it, and it looks in at these different directions and counts these galaxies, and counts their position and their redshift, and that's the basis of these surveys. But that's just a general, I'm not claiming to know exactly how they're doing it, but they're
But
doing
how
this
does the redshift tell you the distance of a galaxy?
Hubble law.
Well,
Okay, well,
that's a
then
bit
my next
circular, of
question is,
course.
what is the
But
Hubble law that
yeah, but
tells you the
I've talked
redshift?
about this. I've talked about this. I did a whole presentation on the Hubble law,
I
on the Hubble
assume that they're
constant.
also from more basic principles, looking at things like Cepheid variables, the periodicity of these stars, and therefore the brightness, and they're using them as sort of standard candles, because they should know what the brightness is based on their period. So, in other words, without assuming the linearity of the Hubble's law, you could possibly do that by
Well,
first.
this is all based on, yeah, you're talking about the ladder distance, cosmic distance ladder. There's, that's, but these surveys are going out real far. I mean, these aren't looking at galaxies that are nearby. When galaxies that are nearby, they measure their brightness, they measure their redshift, and that's used to calibrate the Hubble law. And then they have the Hubble constant, which is the relation gives the relation between distance and redshift. Okay. And obviously, when they're going out, these surveys are trying to go very far out. These are we're not talking about galaxies that are near the Earth. We're talking about galaxies that are way, way far away from the Earth. That their catalog, they've been able to do these galaxy distributions and come up with these diagrams of these distributions that show these distributions of galaxies as you look further and further out from the Earth. And it's a non-uniform distribution. That's the main point. It's not uniform. You have these voids, the areas in it that have very few galaxies. You have areas that you have a lot of galaxies clumped up. You have what they call the Great Wall and the Great Attractor. Vladimir has talked about this. He's, talked about this a lot in his presentations. So we should know about this. I mean, I assume that there was a knowledge and understanding of this, because we've been talking about this for a year now, over a year. So I didn't really go into a lot of detail about that. So, okay. So I don't know where.
Maybe to observe, gentlemen, is that he doesn't accept the expansion of space, the GR ideas. He certainly rejects that. But he does accept a more elementary don't call it expansion if you wish, but objects moving away. And that's giving rise to the redshift. I think I might have had a sort of a brief encounter with him, and he seemed to be. My memory may be playing tricks on me now, but I think he seemed to be pretty averse to the idea of a tired light explanation, which I would favor rather
Yes.
than the velocity one. Did that come out in some of the work you were looking at as well?
Yeah, he mentions that in his papers. Um, he in his papers he looks at, he does basically debunked the tired light. He doesn't like the tired light. So basically, by looking at the redshift, his idea is that the universe is, how should I put this? I'm simplifying this. His idea is that the universe is absolute space and that the galaxies are moving in this absolute space, and that's what the redshift is. And that also means that you're going to get a blue shift because the center of expansion, we're off to the side from the center of expansion. That means that a number of galaxies are going to be coming towards us rather than moving away. And that explains the blue shifts.
So there's more red shift in one direction and more blue shifts in another direction. Is that what we're to understand?
What he's saying is, and this is my understanding of what I think he's saying that there's a center of the universe, okay, and it's 400 million years from us in the direction of the constellation Virgo, okay, and that there's a periodic um, that the universe is like this cyclical Big Bang idea, I think is what he's saying, that the universe has these cyclical events of expansion and contraction, and that what we see is the results of, like, say, for instance, a Big Bang that occurred long time ago, and that would be the galaxies that are really far out. Okay, and they're kind of clumping together in like a ring or a spherical cloud, and then there's another event, and then you get another ring or annular spherical sphere of these galaxies. So you get, here's a bunch of galaxies, and then here's a bunch of galaxies, and a further out. Um, and then there's another bunch of them like this. Okay, now because we're on the side over here as it's expanding outward, there's a blue shift because these galaxies coming towards us. Meanwhile, if you're looking out in the other direction, galaxies are moving farther away and they're redshifted. Does that help you understand? Apparently not. Okay.
What is your opinion about this model? You're an expert in different models.
Excuse me?
What is your opinion, personal opinion about this model? Because most, for me, important is ideas, what he put or anybody put in a new model. What do you think about these ideas and what is your personal point view about his model?
Okay, you're asking me my opinion.
Yes.
Um, I'm not really sure I buying the idea of this repetitive explosion idea. Um, I didn't. I'm not sure I believe in the. He's invented this particle, this graviphoton. I'm not really sure that's probably not too convincing. Um, uh, he doesn't explain the angular momentum issue. He doesn't address angular momentum, which I think is the main point that you brought up, which I think is important. I don't think anybody really addresses the angular momentum. Um, One of the criticisms of Einstein's theory that I think people just don't really deal with too much is that um, Einstein's theory basically is linear motion. Okay, but most of the motion in the universe isn't linear motion, it's circular motion, it's spinning motion. The earth is spinning. The sun is spinning. All the objects in the universe seem to be spinning. They're turning on their axis, or they're rotating around a center of gravity, like the planets are rotating around the sun. There's no linear motion. Okay. So linear motion has a center, and because there's a center to linear motion, that means I mean, not linear motion, circular motion. Circular motion has a center, so that means it's absolute. You can calculate its velocity relative to the center, so you can say it's absolute motion. And so that Einstein's theory is about something that really doesn't apply, in my view. So that we have a whole universe of circular motion in circles. So, but Roger's theory basically assumes that there's an expansion from a center, but that expansion is a linear motion from a linear radial motion. So I'm not really sure that's really, that there are some issues that I have that aren't particularly convincing to me. Does that help you, Vladimir?
Because, let me tell you my opinion about his ideas, because, not some details. First of all, instead of initial singularity, there is a black hole. What does it mean, this black hole? We don't know. What is the mechanism of these
Well, let me
big
stop
waves
you.
of
Let me
galaxies?
stop you. There is um, there he does try to explain this in more detail in some of his other papers, which I didn't really go into detail on. So if you want more, you'd have to read more. Okay, go on.
Let me ask you another question, because in 2013, Thule, with his company in Hawaii, he opened a totally different structure of our galaxies, superclusters, and I demonstrated many times his astronomical results about the clustering of all these galaxies. Did he take into account this new astronomy, not ideas, results in 2013, and he passed away 2022, means, or 24? It means that he had some time to take care about these new astronomical advantages.
Well, you'd
Did
have to,
he?
I can't answer to that. Okay, so here, can you see the screen here? Do you see the?
Yes, yes, yes. Let's continue. I'm very sorry for asking you
Um,
wrong questions.
I agree that maybe what he's claiming is superseded by recent information. That's, but my main point that I tried to emphasize was that in the beginning, I pointed out that his experimental data, he claims that he refutes the assumptions underlying general relativity. Okay. And so there's no, as far as I could see, that information is still valid. I don't see that any of the new information supersedes that. As a matter of fact, they're busy trying to explain away why the distribution of galaxies is not uniform, and why the universe doesn't appear to be according to the assumptions that they're using. So the more information that we have, the more it looks like the assumptions of general relativity and our cosmological assumptions are invalid. So here's the periodicity chart that comes from his analysis of the pencil survey. Okay. This is the Sloan data where he shows, these um, what he claims to be these periodicities. So we see how the galaxies are clumping together in these distances that, he shows there's a center, and then he shows there's this massive clumping. Okay. Can you see that? Is this something that you can see?
It's not spherical, spherical in one direction. I want to see the whole circle with galaxies.
Well,
You see what I mean? It's a
I
cone.
understand what you mean. You're just I'm just pointing out to you this is the data that Jim wanted to know about. Okay, this is, if you wanna not believe it, that's certainly up to you. I'm just pointing out here's his distribution of quasars, his chart for the distribution of quasars. If um, I'm just pointing out that this is a guy that's a dissident scientist who's a pretty smart guy that was involved in the NBA for many years that I personally corresponded with. And he had, these are the ideas that he had. This is the information that he presented. And, certainly, he was certainly ignored by the mainstream. And, um, and so I'm merely pointing out um, to your attention, his ideas. Here's the model fit where he did the fit to the Bessel function, theoretical big wave fit versus the pencil survey data. So he did a fit of his theory to the pencil survey data, and this is the graph that he shows. So this is, I have a theory and I have data, and he's fitting his theory to the data. Okay, and here's his result. This is the way pretty much, they claim that they do science in the mainstream.
Unbelievable.
The Big Bang model of the universe is demonstrably wrong. The galaxies in, I can't see this because of the, anyway. So he doesn't believe in the Big Bang.
Nobody believes.
But he has a new what he calls a repeating big wave. But I think you said that he would conceive of a number of bangs, big bangs, periodic big bangs, and contractions. And I'm wondering, does he proffer any explanation as to how they arise? Is it a gravitational thing, or what, this periodicity of expansion and contraction?
You mute. Harry, you mute.
Sorry, what was that? Yeah. No, I was just asking, is he giving any possible explanation as to how why the universe, well, it's not expanding, why objects are moving away from each other, um, and then are there little big bangs, are there little bangs which have caused those? I don't know if he deals with that at all, but from what you were saying, Harry, it might appear that
Unmute. Harry, unmute. Unmute.
is Harry talking and we can't hear him?
Because he is
Ah,
muted.
I thought he was ignoring us. Yes, we can't hear you,
No,
Harry. You're mute.
he's talking, but he is muted.
Harry, we can't hear what you're saying because you're mute. You'll have to unmute yourself.
Yes.
All right.
Good. You're back.
Okay, we didn't hear anything you'd said in the last few minutes, if you said anything.
Well, all right. Um, all right, we're coming up to the end here. What I'm saying is I don't really have an answer to all of these questions. Um, uh, he's got a website. Like I said, I pointed out how you get to the website. You have to use the Wayback Machine and learn how to use the Wayback Machine. I gave an address for it in a previous slide. Um, uh, there's a lot of papers out there that well, not a lot, but um, there's maybe 10 or so. Um, papers at different places. I'm not sure how repetitive they are. Do they duplicate other papers at other places? I can't really answer to that. Um, I really basically thought that, it's sort of sad that Roger isn't here to defend his own and present his theory. I'm merely being a stand-in to point out what he'd done and what his work is. And if you're interested in learning more, how to go about learning more, and if you want to reject it, then you can just do nothing.
Henry,
But
did
like I
he
did
compare?
say,
I'm sorry.
huh? Go ahead.
Did he compare his theory with some other dissident theories to show what is advantage, disadvantage against some other theories? Or he talked about his own theory without any reference to somebody else?
I think the answer is um, uh, he refers to this book by Mitchell, um, Bye Bye Big Bang, which I'd never heard of. That seems to be his only reference to other. I did mention Bob Histon and Charles Lucas, but I don't think Histon had a cosmology. I don't think Lucas has a cosmology. I could be wrong about that. He's got a whole bunch of books. He was working with those guys, and so what you kind of have is an attempt to sort of I think what his idea is, he was attempting to come up with an alternative to the Big Bang orthodoxy, which he didn't really think really made any sense based on you know what the astronomers were finding. Today, I think we know that what the astronomers were finding um, doesn't really fit the Big Bang. They sort of come gradually, grudgingly coming to the conclusion based on the JWST information that their theories are really bogus and wrong. But it's a very grudging process. It's not something that they're going to say, oh, we decided Einstein's wrong and general relativity is false and the Big Bang didn't really happen. No, I think they're grudging. They're going to hold on to that theory as long as they possibly can and avoid having to admit that Einstein was wrong and the Big Bang was wrong as long as they possibly can. And they'll put ad hoc fixes into their thinking and promote all these fixes to keep the Big Bang and all that other stuff going. But it's pretty clear that the data doesn't really fit the assumptions of the general relativity model that they're using. And that was apparent when Roger was doing this work. So I think that's really the main takeaway. The main takeaway is that Roger's work is an early indication that the Big Bang um, doesn't really make sense. It doesn't explain the distribution of galaxies. So it looks like we lost Vladimir. Okay, do we have any more comments or
Well,
questions
just one
here?
comment occurred to me, in view of what you've just said, Harry, that he may have been at a rather inopportune time because, when he was writing maybe 20, 30 years ago, if one made a statement that the Big Bang didn't seem to be fitting in with observations, one would be dismissed out of hand. But now, because of the JWST and so on, modern measurements, we're beginning to rethink it a little. So I think had he been writing now, he might have had a better audience. Just an observation.
Well, I think you're right. That's why I'm bringing this up. I'm not really sure that there are going to be many people that are going to be rushing off to study Roger Rydin's big wave theory. Hopefully they'll be documented. It's some, I don't know how many people view these cosmology discussion videos, but at least we've got them in the record. Like I did say, if you're interested in Roger's work, he does have videos at YouTube. I was able to find two. In one video, he talks about how he got blocked by the whatever at UVA. He was going to give a colloquium on his theory, and they blocked him from doing that. And he talks about that in his video. And so, if people are interested in learning more about Roger's ideas, there are the YouTube videos. There's the Vixra paper that he co-wrote with Stephen Crothers, where that deals with the Heston's theory and Crothers. Bob Heston had this theory, and it tries to look at Heston's theory and bring that in, and then Charles Lucas's ideas and Charles Lucas's theories and Rogers' theories, and they try to bring that together. Okay, and so there's just more to this than just this big wave idea that I've just basically merely given an overview of. And so there's a lot there. Also, he has this nuclear physics model where he tries to explain the magic numbers. And that's a similar sort of thing that Ito was presenting to us. He tries to deal with the same issues that Ito talked about in his presentation about a month ago that he gave. Same type of thing. So Roger was dealing with trying to deal with the same issues. And I think the important point is Roger is a pretty smart guy. Remember, he was a class valedictorian. He's got PhD. He was professor at the University of Virginia. He's not a crackpot idiot guy. So, shouldn't we be paying attention to this? Mainstream doesn't want to hear about anything, other than that has been approved for publication, by the peer review committees. And the peer review committees seem to be more about blocking than about blocking progress rather than fostering progress. My friend that teaches at local university here, he's all the time complaining about, a lot of the absurd stuff that reviewers bring up, when they review his paper. You didn't, anyway, the whole system really is about preventing free inquiry and not about encouraging free inquiry and new ideas. It's about blocking, preserving the existing status quo, and not about moving forward with new ideas and new scientific knowledge. Okay, we're coming to the end. So do we have okay. Any more comments here before we get to the end?
I was just thinking that if he has done some work with Stephen Crowther.
I'm pretty sure that Bob Heston is dead.
Yeah, okay. Well, Crowther seems to be around. But actually, I wrote to him some time ago, inviting him to give a talk to the Saturday session, and I got no reply at all. Not even refusing. So I don't know. But the reason I bring this up is that if one could get hold of him, he might be able to give us a bit of a presentation on.
Yeah, I thought about that. My understanding is that Stephen is working on getting a law degree
Oh,
because he gave up on science.
Oh, I see. That might
So
explain the reply.
he bagged science and got so frustrated with the mainstream and the way the mainstream blocks dissident science um, that he decided to become a lawyer. So I'm
Because
not.
you know what T.H. Huxley said when it was said in his later life that the bench or the bar had lost a great advocate. He was so uh, capable of explaining things and bringing things together. He said, "Well, yes, I could have become a lawyer, but as far as I'm concerned, I think any small services that I'm able to offer would be in the sense of elucidating matters rather than obfuscating them."
Well, yeah. Okay. I don't really have a whole lot to say unless somebody wants to. Um, I could. Um, any. I think I've tried to answer all the questions. I think I pointed out the big flaw that is I've seen in his the big wave idea is that it doesn't really explain angular momentum. He doesn't address the angular momentum or the spinning issue. And where does the spin come from? Why? And as far as I know, I think Vladimir is the only person who actually addresses that problem. Um, Although the mainstream, they sort of make an attempt at it, um, uh, supposedly, but they
They
then
don't do anything about angular momentum. It's a pollution. Remember this word, pollution. For
pollution.
yeah, them.
Well, the thing is, their idea is that the reason for the nonlinear distribution or the clumping of galaxies, uh, and I think I've said this before, one of my main problems that I have with the Big Bang Theory and their conclusion is, in my view, there's no reason for galaxies to exist according to the Big Bang. So you get a Big Bang, and then you get all this hydrogen, and then you get recombination, and then you get some hydrogen and deuterium produced. Okay, and so now you got these hydrogen and deuterium atoms floating around. And if there's any gravitational collapse, which I think is highly unlikely, it would seem to me that you just get a bunch of stars and you just have a universe populated with stars, you know, forever. Why do you have galaxies? They can't explain why there are galaxies. Why are the stars clumped together into galaxies, concentrated into galaxies? And so that, and they
Mechanism
have,
for this concentration. Collapse. What is the mechanism of this collapse for into galaxies?
well, they claim that there's a nonlinear, that there are fluctuations in the distribution following the Big Bang that they produce a galaxy collapse, a gravitational collapse. I never thought that gravitational collapse made any sense to me. I mean, I don't understand it. They claim they can do these computer simulations that show that they can reproduce the not the spectrum of the galaxy distributions based on this gravitational collapse and fluctuations, but they have to hypothesize fluctuations. Okay. And so that becomes a parameter that you can just freely introduce to your computer models. And so, the models basically only tell us that, yeah, you can make up initial conditions that give you the result that you're looking for. That's all that the models show, in my opinion.
Let me give you a proposal right now for our next session. This one. I was very impressed with your talk yesterday with Roger about IE, about all the theories, Big Bang theory, special relativity, and all this stuff. I would like to continue this talk because I didn't take part in yesterday, but I would like to continue today this talk, and let's talk about what we are going to do with all this special relativity, general relativity, because I tired of these talks. I talk about as a replacement of our own brains, our own, theories. That's why let's continue. Let's put all the points under the over the letters. There is such a saying in Russian about all these theories. We must maybe forget already about it. We must already don't even touch. I do like your today session. You know why? Because at least we are talking about some different dissident theories, not about special relativity, it's obsolete, general relativity, obsolete. Why we are wasting our for these obsolete theories? Let's talk about 3I plus, I atlas right now. There are so many interesting, not only dissident ideas, but new ideas in astronomy. And nevertheless, we are talking about mathematical tricks 100 years ago. Who cares? It's all the story. We must forget we are wasting our time. And what is important, as a society, my opinion, we are losing our face. Face losing. We are talking instead ourselves with our opinion. But higher opinion, it's an orthodox. And we're trying to prove our dissidents' ideas with the most profound orthodox. It's called artificial intelligence, Who trained this artificial intelligence? Orthodoxies. What we're trying to get from this orthodox, trying to prove our own ideas, forget it. That's why, let's stop all this, wasting time, and we're not talking about so many interesting words around, the ideas, new models, new astronomical results, and all this stuff. Why we're wasting time on all this, total obsolete theories, total obsolete results? I don't know. Let's talk. Let's to have a serious talk about it and what we're gonna do as a group and as a society about all this story. Yesterday, you impressed me. You impressed with your ideas, with your approach, with difference with Roger and you. Let's talk about these differences today in a free talk in our group.
Well,
Well,
that's interesting.
I agree that Vlad is making a very valid point here. That to the extent that the dissidents uh, concentrate so much on what happened 100 years ago with Einstein, with all of its mistakes and so forth, it sort of puts us in the past, and it doesn't place us at the cutting edge of science as I think we should strive to be. So I agree with the gist of what Vladimir was just saying.
Well, I'm glad you're saying that
Ah,
because that was kind of what I was trying to do today.
yes,
Uh,
but let's
Well,
talk and let's have some
accepted,
decision about it.
accepted, point accepted.
Yes, yes, I produce, the same idea of what you done yesterday, but we must have, as a society, as a group, some conclusion about it. Stop it. This is my point. I'm tired of all these bullshits about mathematical tricks, wrong, right, and reference to I instead of us. It's a total wrong. Computer cannot replace you, Harry, myself, even Jim, and nobody. And this is the main witness of our dissident theories. Come on, guys. I, I, I use as an assistant. You doing what I'm doing right now, even some letters, very important. I'm doing it such a way. I put all my ideas in a broken English, and then I'm asking this AI to improve my letter. It's okay, but improve only to correct my broken English. Simple like this. This is very good assistant, but never ask for ideas from it because these ideas will be absolutely wrong. Orthodox. Don't name it. don't refer me because there is no value. And to fight against orthodoxy with the most profound orthodox, it's unbelievable, guys. Where is our logic? Sorry for my
Okay.
emotions as
Well,
usual.
one of the things that I did was when I first started out, we're talking about AI, was I asked Gemini AI about Roger Rydin's theory of the big wave. And if you're interested, I can show you what it produced. And I couldn't understand what it was talking about because what it seemed to do was it mixed up his atomic model papers with his cosmology. And I'm not really sure whether AI got it right or whether it just just took a bunch of stuff and tried to combine it together. So I didn't really use what AI told me about Roger Rydin's theory because I found it to be so strange because what it did, as I said, it took it looked at the paper that he wrote with Stephen Crothers and took some and was talking about Heston limit. See, Bob Heston had this theory about, and one of the things he came up with was an equation called the Heston limit. And so the AI was talking about the Heston limit and the big wave, and it just kind of mashed together all these papers that Roger Rydin had written with other people, and it kind of came out as this big mixture of stuff. And I wasn't really sure whether any of it was right or not.
Well, that's what we call artificial ignorance, AI.
That's a good point.
Let me tell you my own story with AI. Maybe 1 year ago, maybe I don't know, about 1 year ago, I asked AI what he knows about my WM model. And you know what was his response? The first one. It's some minor modification of a standard Big Bang model. Unbelievable. I always cried against Big Bang model. It seems to him that it's only modification. What is important? I published to that point 40 papers in a journal. I published over, I downloaded on more than 100 papers on Vixra, on academia, on Research and Gate, and so on. And he knew nothing about my model, nothing. And why? Because he was trained to Big Bang model only. That's why I'm not asking him about ideas. He doesn't know even these ideas I published already. That's why, how we can refer to this monster, orthodox monster, he doesn't know anything about dissident physics. I bet you Rydin, he doesn't know Rydin at all. At all, I bet you. That's why,
Well, I think you know my views. I'm very skeptical about the whole question of AI, certainly the abuse of it. But I was having a conversation with David Hilster the other day, actually, and he seems to be a specialist in the whole area of LLMs and all these type of things. And he said to me that as far as he's concerned, these AI facilities,
Large language models are what
yeah,
they
large
are.
language models, yeah. Uh, these facilities are merely equivalent to automatic fillers. If you have a form, you have to fill out your name and address and your credit card and phone number. You can have a system which fills it automatically. He said that's all AI is. It has no intelligence. It's just an automatic filling in.
yes, there is no intelligence. And we are asking, special relativity is correct, is not correct. There is no intelligence. He cannot answer this question. And you must put some special question that he will answer your question and you will lead it to some your idea. It's absolutely wrong. That's why my proposal very simple. I support Harry. I support Jim. We must stop talking about special relativity, general relativity forever. Forget about it. They are obsolete totally. They don't They don't work at all, especially taking into account considering this GWST new results, because Rydin, he didn't know about it. And he already claimed, oh, it's not homogeneous. He was absolutely right. And who cares? Who
Well,
cares
I
from
don't
Big Bang
quite go
model?
as far as that. I think it's useful to compare the predictions of special relativity or general relativity with alternative theories or alternative results, which might be more in agreement with
There is
experimentation.
no
But what
special
I do think is
relativity.
laborious is just parsing it, going into every single word, going into the German translation. I'm sorry, Roger is here, but going into the metaphysics of it, thrashing it to death. You might mention this once, but going every single day of the year and getting other people in. We've had very good talks from other people like that Scotsman, but going into details about how his algebra is incorrect and how this you could be doing that until the cows come home and you'd get nowhere. So
Yes, it's
I
mathematics
do
only.
think
It's
we've gone
mathematics
excessively into
only,
that.
guys.
But there's no
Let me
harm
ask you
talking about the theory.
one sec, one sec. Special relativity. There is so named speed of light. Please, somebody explain me what does it mean speed of light? Special relativity absolutely wrong, because even definitions of special relativity wrong. Why we cannot compare real physics with some mathematical tricks? It's
Yeah,
mathematics only. And even
yeah.
discussing special relativity, it's, I'm sorry.
This is a problem, and you know, I think what Roger Rydin was really trying to do was really uh, let's get rid of this general relativity stuff. Let's just get rid of, this Big Bang. This none of this, this ideology seems to be valid. And he's got some ideas. He applied the scientific method. That was my point. He applied the scientific method. Here's the data. This is the data. I'm going to take the data and I'm going to put it into my analysis method. He doesn't really talk about his analysis programs and how he does his analysis, but it looks like he's doing some kind of fitting analysis, Fourier fitting, something like that. And he comes out with these periodic distributions, which I think is kind of interesting. So, you wouldn't expect a homogeneous distribution of galaxies to give a periodic distribution, and I think that's his main result. And so his result is, here's the data. This is what the data is showing me. And I need to find a theory that explains this data. And that's where the big wave theory comes from. He's got this periodic Big Bang, as I understand it, a periodic Big Bang events. And that's his explanation of the data. I don't really think it's really particularly convincing. I don't find it particularly convincing. You asked me about this before, but I think it shows that, if we apply the scientific method correctly, we don't get a nice result that confirms what we think we understand. We're not, or the whole thing of the universe doesn't seem to be created by a big bang according to general relativity. It just doesn't.
Yeah, you're absolutely right. Why we are talking about general relativity and special relativity? Even, metaphysically, Roger yesterday he talked about. It's not logic. There is no logic behind all these, notions. One change, another one back and forth and so on. There is no stable theory even mathematically. What is important? Do you know the story of Friedman? There was such a Russian mathematician, and he unfortunately he died long time ago. But what is important? He showed even Einstein. He sent him twice letters about the solution of his equations. Einstein was primitive in equations. Primitive. He took from his equations only static decisions, solutions. Static. Friedman, he showed static. It's not the right way to go. It should be not stable, not stationary, the solutions. And he found this non-stationary solution. The first letter, Einstein answered him, oh, you're absolutely wrong. It's not the right way. The static is okay. But the second one, he prepared the special publication. He showed to journal his solution of these equations. And he showed the Earth must be beginning based on his equation, not even on a Hubble equation. No, Hubble experiments, based on right the solution of his equation. And he done it. Friedman. The Big Bang model is a Friedman Big Bang model. Nobody else, even the beginning, he predicted it. He showed that mathematically it must be beginning of this Big Bang model. And he done it in 1925, long before the Hubble, before all this, Lemercier and all this stuff, all the guys. No, he was the first to propose Big Bang model. There was a beginning, there was this expansion and all this stuff based on the right solutions of the Einstein equations. Einstein, he wrote this equation, he couldn't solve them. Friedman, only he could do it. Guys, and
Okay,
we are
now,
talking about special relativity. I don't know what does it mean, speed of light at all. Why I need to talk about this mathematics? Who cares? And general relativity, we apply, we showed, oh, it's an Einstein Big Bang model. No, Friedman Big Bang model.
correct.
Friedman, guys. That's why even this is wrong. And what is the point? It's in any case, it's mathematics, mathematical equations, mathematical solutions, stable, unstable, I mean, not stationary, not stationary. And that's it, simple like this. And we are trying to accommodate all our new physical results to this base, to these equations. Who is the boss? Physics and mathematics is in service, or vice versa. We have mathematical equations, and now we are trying to accommodate our physical results under these, equations. It's logic. There is no logic at all. Wrong,
Well,
guys,
let me
and we are
just
wasting our time. No,
let me yeah, I understand your point. Let me make a point here about because I want to make this point about Roger Rydin being trained originally as an electrical engineer. As an electrical engineer, the Friedman model tells me that my system won't work because it's unstable. Okay, the Friedman models are unstable. Okay. And as an electrical engineer, I'm going to say, no, I don't like differential equations that go on forever. And no, that's an unstable, invalid solution. Okay. And I think that's kind of how Roger Rydin would have viewed it. You see what I'm saying?
yes, I'm absolutely right. But Einstein supposed that he is physicist. Friedman, he is not physicist. He was not physicist. He was mathematician who knew how to solve his equations. He was a
Right.
mathematician. That's why we're not about physics. And he didn't talk about model. He thought that Einstein's static solution wrong. It must be unstationary solutions. There should be the beginning and all this stuff. It's only mathematics we are talking about, but we are physicists. We are dissidents. Why we're not talking about these mathematical problems, solutions, all this stuff? Because all these two theories, special and general relativity, they're obsolete. We must forget about them. Let's talk about something new, some new ideas, Rydin, whoever. So many different cosmologies around. This is my proposal. Let's stop it. Let's not even name special relativity and general relativity because for me they don't exist. And how many witnesses, even he was against Big Bang model. He's absolutely right. He was. How many other people they're talking about Big Bang model wrong? Why we continue to talk about it? And special relativity, it's a bullshit. It's a bullshit because the very first meaning speed of light means nothing. One way, two ways, cares? It's mathematical tricks only. There is no behind of it. There is things. And Harry, you showed even mathematical tricks and right what is wrong to do mathematics. But you showed not because of because of your brains. You put your brains into this right mathematical solution. But the advantage is only right mathematics. Where the physics? Because C, what does it mean, C? By the way, graviphoton, it's not the notion, proposed by Rydin. There is a graviton in quantum physics. It discussed so many times already. They didn't find this predicted graviphotons, graviton they named as a part of gravitational force because yes, electromagnetic photons and then gravitophotons, gravitons, but never was, and there is no gravitational effects with particles in quantum physics. Forget about it. It's a bullshit. One bullshit. No, there is no
Okay.
gravitons. It cannot be. Gravity is classical notion. It's for ensemble of particles. For in quantum physics, by the way, take a look on all these equations. Never you can see in quantum physics I mean gravitational constant. Never, because it's so weak. They have an excuse. It's so weak. We don't need to take into account. But you cannot put into the quantum physics the so-named gravitational.
Well,
Classical.
here we have another problem, which is quantum mechanics, and yeah. So I think that yeah, I'm not sure exactly how to respond to your long
Response
dissertation
very
there.
simple. Proposal, not only claiming somebody. No, let's talk about something new. As I told you, so many new dissidents. A very good historical view of a new ideas about the big wave. It works, it doesn't work, it doesn't matter. For me to see new people, they knew or they know now that there is wrong something with big bang model and they propose something because to blame something it's easy. Oh, I don't like big bang and that's it. But to propose something new, some new ideas, this is the most important part of any dissident. And let's be dissidence means not blame something bullshit. I mean, general relativity or special relativity. Let's talk about some new ideas and our opinion about them. Do we think? How it works? Might be this idea works. Is this idea doesn't work? And so on and so on. Let's discuss some new ideas and forget
Okay.
about this 100 years ago obsolete theories.
Okay. That's why I did bring in Bob Heston, and I know that he was active in the NPA, and maybe I'll take a look at his ideas and what he was talking about. So I'll try to continue to look at some of these dissident ideas. Heston, maybe Lucas. Um, I don't really, I haven't really. I know Lucas has got a very complicated theory of everything that starts with nuclear models, and he's and so I don't know. Maybe I'll try to look at that and see if we can find something more interesting. Maybe we can talk a little bit about Roger Rydin's work. There's more than I just basically just scratched the surface of it in this presentation. So there's more there to look at, I think.
Yes, but what is not only you, maybe I, maybe Jim, they can produce some new ideas. Not only they're our own ideas, but we like somebody's ideas, somebody dissident theory. Let's talk about them. Let's increase our knowledge about the existent models, existent ideas, existent
Right.
theories.
There's a
Not only you, but all of us.
I did present to Ian a number of people that I'd come up with. I came up with this other guy, Roger Ellman. Maybe I'll look more into Roger Ellman. When I was searching on Roger Rydin, they kept coming up with this Roger Ellman guy. Um, and he's apparently got another theory and some dissonance. There's a lot of people out there, Vladimir, that have dissident
Yes,
ideas, and
yes.
there's more of them than we really know about. Um, and I did point out to Ian. Ian did come up with that one guy. What was his name? Um,
Yeah.
uh,
Um,
I think he was Polish. He lived in Poland. He gave a presentation.
yes, that's right. That's correct, Harry. Yes.
Some of the other ones that I ran across, apparently you tried to contact and didn't get any response. Right.
Yeah, that's right. So I don't know why that might be. I mean, if they they had taken umbrage at an approach, but if they're dissidents, that they might be quite happy to have
Well,
that. So
maybe
I
they
don't know.
don't think of themselves as dissidents.
Yeah, that's possibly the case.
Oh,
Yes.
yeah.
All right, we got 7 minutes here. Um,
Some of them, if they survive right now, to our group and to present their own models, one of the way, Harry, think about it, because why we cannot invite somebody who still alive, simple like this. Don't wait. You know what is my main advantage for my 25 years learning of physics? You know which one? I open for myself, I reveal for myself so many genius people 300 years ago, 200 years ago, 100 years ago, totally forgotten. Nobody knows about the results and their existence. You know how many of these ideas I saturated, I put into my model, beginning from Lisarge and all these other guys, John McCulloch and all these guys. I was happy to reveal all of them, and my understanding of history of physics much better right now. The same story might be with dissidents. If we will open some new names, new ideas, we can collect them. Maybe we can combine them. Who knows what will be the result of it.
okay. All right. Uh, well, I've tried to move in that direction with my talk today about Roger Rydin and
Yes,
try to introduce to you, I- largely because I did correspond with Roger. Unfortunately, he had talked about meeting because he lived not that far from me, but we never did get to meet. So that's kind of an unfortunate thing. Um, uh, so I hope that the talk was worthwhile, even though, like I said, I didn't really particularly find his theory particularly convincing. But as I say, I think it's really just an outline. He was talking about an outline. He didn't really have all the details about how stars form, and and I don't really think the current cosmology really. I really don't find it particularly convincing. How do stars form? They condense by the force of gravity. I don't understand that. I don't understand how stars can form under the force of gravity. I don't. That makes zero sense to me. Um, um, I, how planets form. There's a YouTube video that came out within a week where they claim they discovered a solar system informing that there's some object in the Orion constellation Orion that they claim is a solar system that's being formed, and we can look at it and see that it's forming right in front of our eyes. A solar system is being created, and I'm like, what? That seems like a pretty, but it's really just the same theory. It's like a condensing cloud of gas, that it's spinning disk of that gas that's condensed down under the force of gravity. I
The
don't find
nebular
that convincing.
hypothesis.
Huh?
The
It's,
nebular
Yeah, the
it's not,
nebular hypothesis.
it's not a hypothesis, it's a bullshit.
Yeah,
Because there
bullshit.
is no gravitation between particles. And if you will put these particles in vacuum, they will go out. They will not collect together. It's so obvious. Logic. Where is your logic, guys?
I
The
know, but
beginning of this story, totally
they're
wrong.
they're stuck on this idea that gravity is the so astronomy is about gravity. Astronomy has traditionally been the study of gravity, at least since Newton. It's all been based on, the use Newton's laws of gravity, the motions of the planets, the big famous discoveries in astronomy were the discovery of the planets beyond Jupiter or Saturn, I'm sorry, Uranus and Neptune, that they discovered by mathematics alone, and because using the gravitational law and mathematics, they discovered Uranus and Neptune, that sort of thing. So it's all based on gravity. That's their primary physical law that they base everything on.
Gravity for macro objects, planet, moons, and all this stuff. But gravity between particles, forget about it. This is my main point. That's why you cannot collect cloud. First of all, cloud of these particles, where it came from. Another one, how it collected together. There is no gravitation. There is nothing to force them to go in to each other. That's why
Yeah,
everything absolutely
that's
wrong,
exactly
guys.
my I don't understand how it can happen. I mean, it's just
Cannot. It's everything is wrong. That's why I told you, let's forget about Big Bang model, special relativity, because they don't exist for us. They are against our logic, our brains. They are not against maybe AI, artificial intelligence. It can produce, it can accept, but not us. We have our logic, and let's stop talking about these bullshits.
Okay, we're coming to the end here. All right, I want to thank everybody for being here today. Um, and I guess Jim has got a talk that he's going to give to us next week. Is that correct?
Yeah.
Okay.
I like it.
And
Jim, you are very welcome. As a dissident, you're absolutely right.
I'll be talking about the motion law.
yeah,
Okay,
that's
okay, whatever.
we need to know more. That's a different idea, certainly for sure.
Well, it's in response to Ian's request for, or suggestion that I talk about real data and instead of just computer simulations. So I'm going to talk about the GRACE satellite data and the lunar laser ranging data, which both support the Keen motion law.
All right. Okay.
All right.
So do we? What?
All right. Let's wait. In a week, we will talk about it.
All right. So I guess we're coming up here to the end, and I want to thank you for being here, and I see if I can find out some more about some of the other dissidents who are members of the NPA.